Happy morning to my dear children. Today we are going to discuss about the topic metallurgy. How the metals are extracted from their ores. Before that, we have to discuss occurrence of metal. What are minerals and what are ores? Some common ore and their metal and their composition, concentration of the ore. The first one is gravity separation method. Second one, fourth, flotation process. Third one, leaching. Leaching having 4 types of leaching. One is about the cyanide leaching, ammonia leaching, alkali leaching, and acid leaching. Finally, how to discuss about that. Magnetic separation of the ore. Okay, these are all concentrated of the ore. Okay, let us discuss one by one. Please, all of you take the note. Okay, please, all of you write the equation. Okay, take the note. We can start the lesson. Okay.
Dear children, today our learning objectives to learn about the concentration of ores. The concentration of ores. Okay. So before that we can learn something. Okay. Occurrence of metal. Pure metals are shiny and malleable. Most of the metals found in nature as compound with different properties. Most of the metals are found in nature. Okay. Metal have least chemical reactivity. The least chemical reactivity metals such as copper, silver, gold, platinum occur in significant amount as native element. The reactive metal such as alkali occur in combined state. Okay, and they are extracted using suitable metallurgical process. Anyhow, the reactive metal alkali is in the combined state, and the most least chemical reactivity elements such as copper, silver, gold, platinum, these are all occur in native elements. Next, we can learn about that minerals and ore. This is a very important question, book bag question, the very important question. Okay. What are minerals and what are ores? A naturally occurring substance obtained by mining which contain the metal in free state or in the form of compounds like oxide, sulphate are called as minerals. Here we can learn about what are minerals and what are ore. In most of the minerals that containing less percentage of metal, very small amount of metal are called as minerals. In some minerals, they have high percentage of metal. Suppose we are getting high percentage of metal means that are called as ore. So we can say that minerals that containing high percentage of metals are called as ore. For example, iron present in around 800 minerals. Only few minerals containing high percentage of iron metal. Example, hematite and magnetite. These are the ores of iron. Here having high percentage of iron metal. What are ores? That we can learn about what are ores. Minerals that contain high percentage of metal from which it can be extracted conveniently and economically are called as ores. Okay, so minerals that contain high percentage of metals. Suppose that minerals having high percentage of metal means that are called as ore. Anyhow, from which it can be extracted conveniently and economically are called as ores. Hence, all ores are minerals, but all minerals are not ore. Another one example we can discuss. Aluminium have two minerals. Here I am explaining about two, not two minerals, many having, but I am saying here aluminium having two minerals, that is a bauxite and China clay. Okay, not two, many having bauxite and China clay. Here, what is the formula for bauxite? Al2O3 and N molecules of water. Aluminium oxide, aluminum dioxide, Al2O3 and N molecules of N means number of water. But China clay having is the same Al2O3, two molecules of SiO2 and two molecules of water. Okay, both bauxite and China clay are the minerals, but aluminium can be commercially extracted only from bauxite, while aluminum is extracted from China clay is not a profitable one. What is the reason means? Bauxite and China clay having aluminium metal, of course, but aluminium is extracted from only from bauxite because bauxite having high percentage of aluminium metal. What's the reason? Bauxite mineral having high percentage of aluminium metal. As we are comparing to China clay, it is a minerals because it have a small percentage of aluminium metal. Okay, so as we can be conclude that bauxite is the ore of aluminium. Okay, while the China clay is the minerals of aluminium. Okay, dear children, next we can be learn about a list of some metals and their common ores with their chemical formula. Okay, some of the metals and their common ores with their chemical formula. First I am taking one metal is aluminum metal. Okay, aluminum metal, here I am giving the three ores of aluminum metal. One is about the bauxite. The formula is about Al2O3 NH2O. Next one is a diaspore, that is the formula is Al2O3 H2O. Next one is a kaolinite. The formula is Al2 Si2 O5 and OH 4 times. Next we can be discuss about that iron metals. Okay, iron metals. Here having 5 types of ore there. Iron metals having 5 types of ore. One is about the hematite. The formula is Fe2O3. Okay, what is the formula? Fe2O3. Next one, magnetite formula is Fe3O4. Siderite formula FeCO3. Iron pyrites formula FeS2. Limonite formula Fe2O3 3H2O. These are the ores of iron. Next about we can be discuss about the copper metal. Here also having 5 types of ore there. One is about the copper pyrites. What is the formula for copper pyrites? CuFeS2. Next, copper glands formula Cu2S. Next, cuprite Cu2O. Then malachite CuCO3 CuOH twice. Azurite CuCO3 CuOH twice. These are the formulas about the copper ores. Next about the zinc blend. Okay, zinc metal. First we can discuss about the metal name zinc. What are the ores of zinc? Zinc blend. What is the formula? ZNS. Next calamine ZnCO3. Zincite ZNO. Okay. Next metal is about the lead. Galena. What's the formula here? PBS. Galena. Next, angelcite, PbSO4. Next one, cerussite, PbZO3. Next one metal, tin. It's about the tungstone. What is the formula? SnO2. Next about the silver. Silver also having five ores. One is about the silver glands, argentite, silver glands. What's the formula? Ag2S. Next, silver, ruby silver. What's the formula here, ruby silver? Ag3, Sb, S3. Next, horn silver, AgCl. Next, stephenite, Ag5, Sb, S4. Next, porphyryte, Ag3, As, S3. These are the some formula about the metals for aluminum, iron, copper, zinc, lead, tin and silver. Okay, please learn this one. Next, about the concentration. Today our learning objective is about the concentration of the ore. What is about the concentration of the ore that you have to learn? Listen all of you. Concentration of the ore is nothing but first we have to remove the impurities from the ore. Okay, what is about the concentration of the ore? First we have to remove the impurity from the ore. Here the ore is associated with non-metallic impurities, that is some rocky impurities, siliceous matters. Okay, this siliceous matter means we are saying the sand waste. Okay, like that, which are collectively known as gangue. Gangue means impurity. The ore are associated with non-metallic impurities, rocky impurities, siliceous matters, which are collectively known as gangues. Okay, first we have to remove these impurities. How we can be remove these impurities means they have many process having. Okay, they have some many process. Anyhow, this removal process is called as concentration of the ore. This removal process is called concentration of the ore. Okay, first one, gravity separation. We have many processes having gravity separation, fourth flotation process. We have many separation having. Okay, today first process is about that gravity separation. What is a gravity separation? Means we are washing with the water, hydraulic washing with the water. For example, the ore having high specific gravity is separated from the gangue have low specific gravity by using running water. Simply we are using a ore is washed with running water. That process is called what? Gravity separation. Listen all of you. First, the ore is crushed and finely powdered and treated with the flow of running water, a speed of running water, a current of water. Can you understand me? The ore is crushed. The ore is crushed and finely powdered and treated with the flow of running water. What happens during this process? The lighter particles are washed away. Okay, what happened? The heavier particles, they will settle down. Okay, the lighter particles will be washed away. For example, hematite and the tin stone. What is the formula for hematite? Fe2O3. What is the formula for tin stone? SnO2. Okay, next. We can be discuss about the very important question, that is about the fourth flotation process. Okay, what is about the fourth flotation process? This method is commonly used to concentrate sulfide ore. Sulfide ore means sulfide. For example, galena. What is the formula for galena? PBS, galena. PBS. And one more, where we are taking zinc blend, EZNS, zinc blend. Okay, already we learned galena and zinc blend, everything we learn, am I right? Okay. In this method, the metallic ore particles, which are preferentially wetted by oil and can be separated from gangue. What is gangue? Impurities. Okay, some of the gangue means impurities. Okay, in this method, the metallic ore particles which are separated, which can be wetted by oil, can be separated from gangue. In this method, First, we are taking one of an iron tank, one of the tank. Okay, one iron tank or any other tank. The crushed ore is suspended in water. The crushed ore is suspended in water and mixed with the fourthing agent. Fourthing agent means we are using here pine oil, eucalyptus oil. These are some oil we get fourth. Okay. Fourthing agents such as pine oil and eucalyptus oil. Here we are adding a small quantity of sodium ethyl sandate. Okay. What are you taking here? A small quantity of sodium ethyl sandate which act as a collector. Okay. Which act as a collector. The molecule attach to the ore particles and make them water repellent. Water repellent. Water is not attachment there. Water is removing. Okay. Water repellent. In this method, fourth is generated. In this method, fourth for this, look the picture all of you, this diagram, here fourth is generated, am I right? Anyhow, by blowing air, fourth is generated by blowing air through the mixture. As a result of four particles wetted by the oil and raise the surface along the fourth. This fourth containing what? The sulfide ore having, am I right? So anyhow, in this method, the fourth is generated by blowing air. This way we can blow the air through the mixture. As a result, the ore particle is wetted by the oil and raise surface along the fourth. Okay. These ores are skimmed off and tried to recover the concentration of the ore. Okay. The gangue particles are wetted by water settled at the bottom. Below here, the gangue particles are settled down. The above and the fourth they are having the ore particles. Okay. Here, one more important point about the sulfide. Listen all of you. Here, one more important point about the sulfide. What is that one means? The sulfide ores are interfering. How it means? When the sulfide ore of the metal contain other metal sulfide as impurities. Can you understand me? Here it is a sulfide ore. Here having other metal sulfide as impurity. Here we are using a depressing agent. Depressing agent means sodium cyanide, sodium carbonate. Okay, what is the formula for sodium cyanide? NaCN. What is the formula for sodium carbonate? Na2CO3. To prevent other metal sulfide from coming to the fourth. Can you understand me? When a sulfide ore of the metal contain another metal sulfide as impurities. Here we are using a depressing agent such as sodium cyanide and sodium carbonate to prevent other metal sulfide from coming to the fourth. For example, when an impurity such as zinc sulfide is present in galena, what is the formula for zinc sulfide? ZNS, zinc blend. Don't forget that. ZNS, zinc blend. Okay. Present in galena. What is the formula for galena? PBS, galena. Lead sulfide, PBS. Here, sodium cyanide is added. Sodium cyanide formula NaCN. Sodium cyanide is added to depress the flotation property of zinc sulfide by forming a layer of zinc complex. Can you understand me? When the impurity such as zinc sulfide is present in galena, one of the impurities that is called as a zinc blend is present in galena, we are adding sodium cyanide. Whenever we are adding the sodium cyanide to depresses the flotation property of zinc sulfide by they are forming a layer of zinc complex. What is the complex there? Na2EZN four times. Na2EZN 4 times. Okay, on the surface of zinc sulfide. Okay, what is the complex name? Can you say the complex name? Sodium tetracyanosyngate sodium, tetracyanosyngate is complex name. Okay, this is about the fourth flotation process. A very important question. Try to learn about the fourth flotation process. Okay, next we can be learn about that leaching. What is about the leeching? Okay, leeching means in this method the crushed ore are allowed to dissolve a suitable solvent. The crushed ore, the powdered ore or crushed ore is allowed to dissolve in a suitable solvent. We are taking one solvent. That solvent we are dissolving the crushed ore. The metal present in the ore is converted into soluble salt or complex, while the gangue remains insoluble. Can you understand me? Here, the crushed ore is allowed to dissolve in a suitable solvent. The metal present in the ore is converted into soluble salt or complex. The gangue remaining insoluble. There are four types of leaching. One is about the cyanide leaching. Second one is the ammonia leaching. Third one is the alkali leaching. Fourth one is the acid leaching. Okay, there are four types. One is about the cyanide leaching. Here we are taking the solvent is cyanide. Okay, cyanide we are taking. Here cyanide leaching means the crushed ore of a gold is leached with a dilute solution of sodium cyanide. Here gold is reacting with the cyanide, sodium cyanide. Here treatment with the sodium cyanide. So we get one of the complex. What is the name of this complex? We are getting one complex formula is AuCN2. AuCN2, one of the complex we are getting. Dicyanidoarate ion. Dicyanidoarate ion. Can you write the equation? Gold reacts with cyanide ion in the presence of oxygen plus water gives one of the complex and also we are getting hydroxy group, OH group also having. Okay, try to balance the equation. Don't forget that to balance the equation. Write the equation. Okay, next about that, next topic about this. Here we get the gold we are getting, but this gold, we are getting a gold complex. One of the complex we are getting here. From this complex we can be recovered the gold by the reaction between zinc. We are adding some zinc solution with the zinc. In this process, gold is reduced to its elemental state, and this process is called cementation. Okay, one of the important 2 mark question. Anyhow, this complex I am taking, this complex plus zinc I am adding zinc metal. So we get what? Gold. Gold is recovered. And next we get one another complex. What is the name of this complex? The tetracyanidosyngate ion. Tetracyanido, because one there is 4 cyano group is there. 1 means mono, 2 means di, 3 means tri, 4 means tetra. Tetracyanidosyngate ion. Okay, this complex name we have another one lesson. I will explain there. Okay, another one. I think that coordination chemistry lecture we having, we can be explained later. Okay, next one is about that ammonia leaching. Here we are taking one solvent is called as an ammonia. Here, when a crushed ore containing nickel, copper, cobalt is treated with ammonia. Okay, we get some complex here. Which are the complex getting means? One is about that NH3 6 times 2 plus Cu, NH3 4 times 2 plus CO, NH3 5 times H2O 3 plus. These 3 complex we get. Okay, can you say the name of the complex? Okay, first ammonia means we are saying amine. Okay, amine. How much ammonia is there? 6 ammonia. So 6 means hexamine nickelate ion 2 plus nickelate 2 ion, hexamine nickelate 2 ion. Here CuNH3 4 times, 2 plus here saying 4 ammonia is there. Tetramine, copper 2 ion. Here CuNH3 5 times, H2O3 plus. Here we have 2 ligands. These are the ligand. I will explain you later. Okay, so another video I will send. Okay, how much ammonia is there? 5 ammonia. So pentamine, water. We are saying here, aqua, pentamine, aqua, cobalt 3 ion. First one we can be say, what is the first one? Hexamine, nickel 2 ion. Next one, tetramine, copper 2 ion. Next one, pentamine, aqua, cobalt 3 ion. Cobalt 3. Next, we can learn about the alkali leaching. Here, the ore is treated with aqueous alkali to form soluble complex. For example, bauxite is an important ore of aluminum. Okay, this bauxite ore is heated with sodium hydroxide at the temperature is about 470 and 520 Kelvin and 35 atmosphere pressure to form sodium meta-aluminate. That means bauxite is dissolved in sodium hydroxide solution. We get sodium meta-aluminate. What is about the equation? Al2O3 plus NaOH plus water gives NaAlOH 4 times. Okay, this is the equation. First, how much aluminum is there? 2 aluminum. So here also make it 2. So how much sodium is there? 2 sodium. Make it 2 here. Okay, then sodium also balance. So here how much hydrogen is there? Hydrogen is 4, 2s are 8. So here also 2 over. Then we can be 3 into 2 is equal to 6. The equation is balanced. Next, the solution of sodium meta-aluminate, this on react with carbon dioxide gas. We get Al2O3 plus water, Al2O3 water and including sodium bicarbonate. We are getting alumina, okay, Al2O3. We get a pure alumina, pure alumina, formula Al2O3. So how can you balance the equation? Here 2 aluminum is there, so make it 2 here. Okay, now how much sodium is there? Sodium, here 2 sodium. So here how much carbon is there? 2 carbon, so make it 2 here. Now the equation is balanced. Next about the acid leaching. Okay, it's the last leaching. Anyhow, the leaching of sulphate or such as zinc blend galena can be done by treating them with a hot aqueous sulfuric acid. That means zinc sulphate reacts with hot sulfuric acid in the presence of oxygen. We get zinc sulphate and an elemental sulfur with water. That means ZnS plus ZnS plus sulfuric acid. What's the formula? H2SO4 plus oxygen. We get zinc combines with sulphate. We get ZnSO4 and also we get an elemental sulfur S plus water. How can you balance the equation? Here having only 1 oxygen is there. Here having 2 oxygen, so make it 2 here. So 2 moles of hydrogen. So make it 2 moles of hydrogen here. So total sulphate also make it here 2 sulphate means here also make it 2 sulphate there. Then how much zinc is there? 2 zinc, so make it 2 zinc there. Okay, now the equation is balanced. Okay, can you write the equation? If you have any doubt means please ask me. Okay, next about very important question is about the magnetic separation. What is about the magnetic separation? Don't forget that the separation of magnetic force from a non-magnetic impurities. Okay, the separation of magnetic force from non-magnetic impurities. We know that the magnet force particles are attracted by magnet. I'm right. That means this method is applicable to ferromagnetic waves. For example, tin stone can be separated from wolframite impurities, which is a magnetic. And also chromate ore. Chromate ore is also a magnetic property. Okay, can be removed from the non-magnetic siliceous impurities. Here, what is an experiment means, the crushed ore is poured into an electromagnetic separator. Consists of having belt. Look the figure. This figure here having one belt. This belt is moving over the two rollers. Here having two rollers. This is one roller and this is another roller. Okay, this roller containing some magnetic attraction. Okay, here having some magnetic attraction because it is a magnetic wheel. Am I right? Anyhow, out of these two roller, one is a magnetic and another one is a non-magnetic. There are just one belt. Am I right? The magnetic particles of the ore is attracted towards the magnet and falls into the keep. They're having two keep. Am I right? One is falling magnetic ore, another one is falling non-magnetic ore. Am I right? Look the figure thoroughly. Okay. Anyhow, the magnetic part of the ore is attracted towards the magnet and falls as a keep close to the magnetic region, while the non-magnetic part falls another one keep. Okay. Can you understand, dear children? Okay, anyhow, today we learned such a questions. So, anyhow, okay, my dear children, today we learn about that minerals and ores and some metals and their common ores with their chemical formula, concentration of the ore, gravity separation, fourth flotation process, leaching, and about that magnetic separation. I'm right. So today I'm giving the assignment. Try to learn the leaching. Okay, leaching. You have, I think that 4 or 5 equation. Try to learn the equation thoroughly. Okay. Anyhow, thank you all. Thank you. Have a nice day.